In this video, we're going to do some extra examples that use the chain rule. So let's just jump in here. So for part A, in number 1, I have a function 4x multiplied by a function 3x plus 5 all to the power 5. So here we need to use the product rule. Okay, so we have our first function is 4x, and our second function is 3x plus 5 to the power 5. So if we want to take these derivatives in advance, u prime of x is just 4, whereas v prime of x, I need to use the chain rule. So it's my inside function is 3x plus 5. So it's going to be something to the power 5 is what I want to take the derivative of. So it's going to be 3x plus 5 to the power 4 multiplied by the derivative of the inside, which is 3. So this is going to be 15 times 3x plus 4 to the power 4. So now, when we use the product rule, y prime is the derivative of 4x times 3x plus 5 to the power 5 plus the derivative of 3x plus 5 to the power 5 times 4x. Okay, we've already computed these derivatives, so this is 4 times 3x plus 5 to the power 5 plus 15 3x plus 5 to the power 4 times 4x. So I see that I can take out a 4 and also 3x plus 5 to the power 4. Okay, so in the first one I'm going to be left with 3x plus 5, and the second term I'm going to be left with just 15x. So simplifying in those square brackets, I'm going to have 3x plus 15x, that's 18x plus 5. So there's my derivative and in factored form. Okay, let's try another one. So here I need to use the quotient rule. I'm going to do this one directly without doing the derivatives before. Okay, so f prime of x is going to be the derivative of the top. So the derivative of x squared minus 7 to the 9 times the bottom minus the derivative of the bottom times the top. Oops. Okay, all over the bottom squared. Okay, so the derivative of this first one, I need to use the chain rule for. So it's going to be 9x squared minus 7 to the power 8 times the derivative of the inside, which is 2x. Okay, and all of that is times 3x plus 2. The derivative of 3x plus 2 is just 3, and that's going to be multiplied by x squared minus 7 to the power 9. And all of that is over 3x plus 2, all squared. Now I can do some simplifying here. I see that I can pull out 3x squared minus 7 to the 8. And in the first term, I'm going to be left with 6x times 3x plus 2. So why 6? Well, I took a 3 from here, so there's 3 left. And then I have this 2, so 3 times 2 is 6. And then from the second term, I just have an x squared minus 7, an extra 1. And this is all over 3x plus 2, all squared. And now I can simplify in this bracket. So I expand here, expand the negative through. So it's going to be 3x squared minus 7 to the power 8 times 18x plus, x squared times 12x minus x squared plus 7. And that's all over 3x plus 2, all squared. Combining like terms, I see that this is 3x squared minus 7 to the power 8 times 17x squared plus 12x plus 7, all over 3x plus 2 squared. Okay, so that would be my derivative. Okay, and then we try some with some exponentials involved. So when I'm taking the derivative of y, so first of all, I can take the derivative separately. So it's the derivative of the first term, okay, minus the derivative of the second term, which is just 10. So this derivative is 0. Okay, so we don't really need that there. And then in this one, I need to use the product rule. So this is the derivative of e to the 2x times 5x minus 1 cubed plus the derivative of 5x minus 1 cubed times e to the 2x. Okay, and then it was minus 0 if you want that there. So what's the derivative of e to the 2x? So this is my inside function, the 2x. So the derivative of e to the something is just e to the something. Okay, but then I need to multiply by the derivative of the something, which is just 2. Okay, now over here, my inside function is 5x minus 1. So the derivative of something cubed is 3 something squared multiplied by the derivative of the something, and I get multiplied by 5, and that's times e to the 2x. Okay, now again, I can factor out e to the 2x and also 5x minus 1 squared. So what I'm left with in my first term, I have a 2 and one more 5x minus 1. And in the second term, I just have 15. Right? Because I took the e to the x and I took the 5x minus 1 squared. So I have the 3 and the 5. So simplifying inside those brackets gives me, so I'm going to have 10x minus 2 plus 15 is going to be plus 13. So that would be my derivative. Okay, what about the quotient rule? So f prime of x, so it's going to be the derivative of the top. So I'm taking the derivative, okay, maybe I'll write this. So the derivative of 2 to the 5x cubed, okay, times the bottom, minus the derivative of the bottom times the top, okay, all over the bottom squared. So when I want to take, so here, okay, here's my inside function. So I'm using the chain rule. So the derivative of 2 to the something is 2 to the something, okay, times ln 2, and then I have to times by the derivative of the something, which is going to be 15x squared. Okay, and that's all times 2x minus 1 to the 4. And then over here, my inside function is 2x minus 1. So the derivative of something to the power 4 is 4 something to the power 3. Okay, times the derivative of the something, which is 2, and then times the original function. And then when I square this thing down here, it's actually going to be 2x minus 1 to the 8. So I'm going to multiply those exponents. So now I want to look for like term or common factors. So I see that both terms have this exponential function, so I can factor that out. And both terms have 2x minus 1 to the 3. So I'm going to take out 2 to the 5x cubed and also 2x minus 1 cubed. And what's left from the first term, I'm going to have ln 2 of 15x squared and one more 2x minus 1. And then over here, I just have 8. Okay, and this is all over 2x minus 1 to the 8. Now I can cancel those 3 with 3 of these. Okay, so that's nice. And there's not very much simplifying. There's no simplifying really that can happen in those brackets, so I'm just going to leave it. So this is going to be 2 to the 5x cubed, okay, times ln 2 times 15x squared times 2x minus 1 minus 8 all over 2x minus 1 to the power 5. Okay, let's try some trig ones. So again, okay, I have a product rule here. The 3 can just go with this first term if you want, or you can pull it out and multiply it at the end. So g prime of theta is going to be the derivative with respect to theta of 3 sine of 5 theta times tan to the 4 theta plus the derivative with respect to theta. Now I'm just going to write this a bit differently. So tan 4 theta is actually tan theta to the power 4 times 3 sine of 5 theta. Okay, so when I want to take these derivatives, I need to use the chain rule. So here's my inside function. So the derivative of 3 sine of something is going to be 3 cos of something. Okay, and then times the derivative of the inside, that's just 5. And then we have to times by tan 4 theta. Okay, over here, my inside function is tan theta. So I have something to the power 4. So it's going to be 4 something to the power 3 times the derivative of tan, which is secant squared theta, times the 3 sine of 5 theta. Okay, let's just clean this up a little bit. So I'm going to have 15, when I put the numbers together, cos of 5 theta times tan to the power 4 theta, plus here I'm going to have a 12, and I'm going to have sine of 5 theta times tan cubed of theta times secant squared theta. There's not very much, this is fine. I'm going to leave it like that. Okay, so the cosine and the sine are 5 theta, so they cannot go together with the regular thetas. Unless you use an identity or something, which we're not going to do. And those two could go together a bit, but not in a useful way. So let's try one more. So I have 5 times this whole thing. So we can either pull the 5 out and multiply it way at the end, or you could put it up on the top if you want. Okay, either way, I'm just going to leave it out. Okay, so the derivative here is going to be 5 times, okay, and then I'm going to use the quotient rule. So it's going to be the derivative of the top, okay, times the bottom, minus the derivative of the bottom, and actually again I'm going to rewrite this so you can clearly see the inside bit. Okay, times the top, all over the bottom, squared. Okay, so here is my inside function here. So it's something to the power 7. So it's going to be 7 something to the power 6 times sine cubed of 2x. Okay, now over here I actually have a multi-level chain rule. So first of all, it's sine of 2x. That is the inside bit. Okay, so it's going to be something to the power 3. So that's going to be 3 something to the power 2. Okay, now I want to multiply by the derivative of sine 2x. So now my inside is just 2x. Okay, so the derivative of sine of something is cos of something. And then I need to multiply by the derivative of the something, which is 2. Okay, so all of that is the derivative there. And then we still have this 3x plus 2 to the power 7. And down here, this is sine cubed and then all squared, so it's going to be sine to the power 6 down here, because I want to multiply those exponents. Okay, now I can do a bit of simplifying. I'm going to keep the 5 out for now. So I can pull out 3x plus 2 to the power 6, and also sine of 2x to the power 2. Okay, so then here I'm going to be left with 7 sine of 2x. And then the next term, so I took this out, and I took almost all of these. So I'm going to have 6, the 3 and the 2, the cosine of 2x, and then 3x plus 2, one more to the power 1. Okay, all over sine to the power 6 of 2x. Okay, so now I can cancel, so this goes away, and I have only 4 down here now. And I'm going to just move the 5 in up here. Okay, so this is 5, 3x plus 2 to the power 6 times 7 sine of 2x minus 6 cos of 2x times 3x plus 2. Okay, all over sine to the power 4 of 2x. Okay, and that would be my final derivative. So that was a few examples using the chain rule.